Yeah, cool. So yeah, okay, let everyone come back again. Yeah, let Pavitra and Wilson join. Yeah, Pavitra is coming. Yeah. Yeah. Hi, everyone. Yeah, cool. Okay. Right, let's carry on. Yeah, 1 second, please. Wilson's coming. Cool. That's Pavitra. Okay. Right. Okay. So the static factory method is just that, right? So if you have a companion object, that's your static factory method. Remember, we studied about objects before. What is an object?
An object is a template of a class.
Oh, yeah. Oh, yes, that's correct. That's correct. Yeah, that's the basic fundamental. That's the basic foundation, right? But what I'm saying is, I mean, when you say object in Kotlin, what is it?
Oh,
Remember the first design pattern we studied.
yeah. An object.
What is it? If I say
Oh, a singleton.
that's it. Boom. Yeah. So we use this object keyword for two things. Yeah. One for creating a singleton class, and also to create a static factory method. Yeah. So you have to have a companion object. So this is also an object, but this is to create the static members in the class. Yeah. So those are the two places you can have object keyword in Kotlin.
Right.
Yeah. When you create, if you just say object, that's a singleton. But if you create a companion object, that's becoming a static way of calling some methods or anything, a variable or a function in your class. Yeah? Right. So that's why we could be able to just call this a static way, because I mean, I don't need to create the instance of this server class. I can just access this with the class instance. That's why I can just say dot. I don't need to create an instance of this server class. Yeah.
Yeah.
Yeah. Same, exactly the same as in Java. We can access a method if it's in class level, but it has to be marked as static. Yeah. So this is the static way of accessing it, and that's why it's called static factory method too. Yeah. So we're going to go back to our previous example, and can we think of that? How can you? Charity's here. How can we apply the static factory method in this example rather than having a factory method? See, this is a factory method, right? Hi, Charity. Hey, Charity.
Hello.
Hey, man, how are you?
I'm fine.
Good.
I'm late a little bit.
That's okay. Yeah, we haven't gone much, I mean, we haven't covered much yet, so we have just started looking at the next design pattern, which is the static factory method. Yeah. So we haven't gone through much, so yeah, I can show you quickly as well. So what we did was, so we created this static factory method. So we have a class here, and we restrict the constructor to be private. So no one can instantiate this. No one can create instances of this class. Yeah. But
Yeah.
we made a static factory method with the companion object in Kotlin. This is exactly like in Java. You can say a method static. So this is the same in Kotlin. To make something static, you need to say companion object. Yeah. Yeah. Just the name difference, but it's doing exactly the same. So now I don't need to instantiate this class. Instead, I can just call the method straight on it because if it's on the class level, because of this is treated as a static method, because of it's within the companion object. You see? So yeah, so this is also about creating objects, right? So I've just created an instance, which is the class instance. Yeah, see here, because I create the instance here whenever this static method is called, by restricting this class not to be created through constructors. So yeah, that's static factory method for us. Yeah. So there's another way we can make use of this. If you ever want to block the server sorry, with the class creations with the constructors, but through our own static methods, yeah, then we can do this. Yeah, that's the purpose of having a static factory method. So I'm thinking, so this is just, we've just seen, as how to use this. And we're going back to the previous example to see, how we can apply that on that previous example. So the previous example was talking about, how to use a factory method. So this is just the factory method, right? So if you ever have a factory method, we can create our own kind of object. Yeah. Yeah, so we can use our same kind of objects in it. Let me mute you for now. Yeah, so right, so how do we do this? Static factory method is also to create objects, right? It's a creational pattern. So how can we change this design we have using static factory method rather than a factory method? Can we look at this and think of anything? Guys?
We can do two static methods.
Yeah, where will we have companion object? So static factory method is companion object in Kotlin, right? So where will you
sorry.
Yeah, where will you put that in the companion object? So we want to basically create chess pieces, no? Yeah, so that's the class. We can have our companion object. So here we can have a companion object and say and yeah, this we can push that to here. No, sorry. So this is receiving positions and type per piece, and I want to create one piece at a time. So it'll be all this will go into that. Yeah. Well, actually, I don't want to change this here. Hold on, because we want to keep that. Let's create. So this is example 1. Yeah. Let's create the example 2. Right, and let's copy all these. No, not really. Yeah, we need only these. This as well. Yeah, say addition. These are the, what is it? Decisions or something. Yeah. I'm just renaming it because it's in the other file, we have the same names, so it's conflicting with them.
Oh, okay, yeah.
Yeah. So chess piece, let's call this chess. Or let's just say piece, yeah. These are the piece. This is the, yeah, so we know it's the chess piece, no? So I'm just changing them like that. Chess positions. Boom. Yeah. No, sorry. Yeah. Okay. So this is the piece print method. And yeah, this is also the create. Let's rename this because there's a function already there. Yeah, okay, cool. And then set a piece. So just what's the problem? Yeah, here. Because I've called this name, called this field class as piece, so yeah, now it's fine. Okay, so I've just copied the same, but I'm going to change this to using the static factory. Yeah. So we said if we have a class piece, I can have a companion object here to create my pieces, right? like so that I can have a static factory method instead. Yeah. So I'm going to say create piece. Yeah. And how am I going to create this? This is the function. So to create the piece, what we want these, right? Those three things. No? Every time, if you want to create a piece, we want these. Yeah. So that should be given. But these are, of course, yeah, they will be given. And I'm going to create them. So if I know all that, I can just I can use this when statement like we had it before to create them. No? Yeah. This is the piece. Yeah. So I don't need this when statement now, but then, so this is my static factory method. Create piece is here. But then I'm checking what's the type, exactly like what we did before. And yeah. So it's going to give us a piece every time I call this create piece. So how do I now call this in the main method? So if I now need to call this, I can, yeah, so I'll receive, so this is the given strings. So I'll take that and I'll do the looping here outside because I have the objects now inside getting created, right? And I'm going to call the piece dot create piece with this, no? Yeah, so it's going to give me, it's going to create the pieces like we did before. So I don't need this factory method anymore. Yeah. Yeah, and it's done. So it's exactly the same thing is done, but now we're using a static factory. So this is being that static factory method.
Mm.
You got it? Did you see it? Yeah.
Yeah, it's
Yeah, so we can do it both ways, you see, but you need to decide, where do you want to have your method telling about, how to create the objects. This is also valid because I have now pushed the creation of object into the class itself, right? Before,
right.
yeah, we said I have this, which is going to take the responsibility of creating the classes as this being the factory method. So I would have, yeah, I would, if I want to access this, and I would need to create, if this is in a class, yeah, I would need to create an instance of that to call this factory method.
Okay.
Yeah, but here, this is as being outside, yeah. But if I now push this into a piece itself, which is a class, still class, but I mean, belongs to all these pieces definition we have, we can now push this creation into each piece as well, because that could that could live there as well, isn't it? Because we know if anyone reads this class, they can see the immediate relationship, I mean, the hierarchy of the classes, and they can see, this is how I myself can get created, so everything is staying in here, every single bit which relates to a piece is staying here, the hierarchy definition and how it's getting created, but of course, because this is being the companion object, we can just call this to create it like this,
Right.
Yeah.
Please.
Yeah. So this is another example of you using the static factory method to create objects. Yeah. Yeah. Do we want to spend a bit more time getting head around this, or more questions, or what do you think?
Yeah, so the just from what I'm picking up is the benefit of having a static factory method is when it's called,
yeah,
you don't have to instantiate the class. Is that right?
Yes, because of it's yeah, that's 100% correct. Because of it's static factory method, isn't it? Static method means you don't need to instantiate the class. You can just call it.
Okay.
And how do you create a static factory method in Kotlin? using a companion object.
Companion object.
Yeah, so this companion object means, you know, this is all the functions we create inside are going to be static functions, you know. Yeah, so that's another interview question. What is a companion object? You could say, I mean, that's where you can have the static factory methods, or, you know, if you want to access something class level, you know, that's it. Yeah. Yeah. And yeah, I don't want to confuse too much, you know. Sometimes, I mean, we put our constants here as well, you know. So if anything related in the class and which are constants, you know, which they can be belonging to the class, not the instances, I can create my no, actually constant here, you know, constant or something, and then I can call this as well, you know.
Oh yeah, Farouk, I wanted to ask you about sealed classes.
Yeah.
Is it true that the enum
Mhm.
got thrown away and the sealed class takes its place?
Not really. I wouldn't say no completely. That's another
Oh,
interview question, though. You know, people ask, you know, what is a seal class and why is it different from enums? Enums, yeah, that's good that you've asked, because, you know, I mean, this is really good to compare now, you know, because as we're studying seal classes, enums, you have them to just define one set of constants, you know, even though they have the hierarchy. They are good for telling a hierarchy, but they will always have one set of constants, right? But seal class go a bit further. The foundation of the seal class is the same. It tells you a hierarchy of some classes, and it will have always the one set of constants, like in this example here, peace will have the one set of constants, right? So king, queen, they are the types. They are the different pieces types. But it will let you even go further. I mean, I can break this. See, this king as being a piece, I'm telling it's a piece, but I can create another set of group under this. Like for an example, I can say, yeah, if there are different types of kings now, yeah, so I can break them even further into it. So data class, say, I don't know how
white king or black king?
yeah, that's a good one, man. Yeah, well, you helped me with that name. That's very good. King, white king now can be another one, val type or something. Sorry, type char. Let's keep it like that. But he is the king now. You know what I mean? Actually, pass all this as well. I'm even breaking this further down now. Okay? And then pass this into the king. Oh, okay. This data class is already closed, you know. So, but then for that, I mean, if you want to hierarchy, if you have further hierarchy, then you have to break it, you know, and make this open. Yeah, you can do that.
Oh, okay, make it open.
Yeah, make it open, and then yeah, that's the data class as well. But then don't keep this as a data class, and just for the sake of, you know, I mean, no need to define them as vals as well, you know. So you can do this. So now I have created a white king, which is a king. But what is a king? King is a piece. So now this guy is also treated as a piece. See, now
Right.
win condition will go wrong. I mean, where's that? Yeah. No, because of these are the pieces we're checking, but not the king. But if I even go further, I can say is king dot sorry. No, sorry. No. I can do that there. No. This is we're checking the piece, no? And then here maybe probably I'll do that. This is the king is yeah, you see? Then do this. So I'm checking all possible kind of pieces, but inside the king, I have different types now. You know, that's allowing me to even go further the hierarchy in it. You know, so but the const yeah, so the enums in this case, you can only have one set of enums. You know, one set of how do you call it? So if you say this is an example of enums, right? If you say month, that could be enum. So you can only have Jan. You can only define these Jan, Feb, March, and things like that. You can't go further and break the January into another type or something, another 2 different types or something like what we have just done. So
Right.
I can simply put another one now, which is black, or something. See, I've created further types within the types. So and there is no limit. You can break them into more further and further. But that's the class. We'll group everything as the same because you can't say white king is not a piece, isn't it? It's coming under the piece. That's the parent. That's the top in the hierarchy. But with enums, it's just always one set of constants. So you can always have it one, and you can't have January split it into further types of months and things like that. So if you always have just one set of constants or one set of hierarchy, then choose enum. There's nothing wrong with that. It's still available in Kotlin. As you can see, it's there. But
no, it was just something I heard on the internet, and I didn't know if it was true or not.
No. I mean, people still use it in the code. I mean, if it's just one set of constants, why don't you use it? Simple as that. Like I see, I mean, if I want to define months, that's perfect. Months, or if I want to define the days of week, Monday to Friday, Monday to Sunday or something, I can use an enum because I don't see putting this into a seal class is too much overkilling. Because what's the hierarchy? It's always going to be one set, right? So, we don't need it. You don't need the seal class for that in that case. I mean, I've seen Google. If you have any doubts like that, and if somebody's telling this in Stack Overflow, it's always better to go and check the Google references. That the sample apps they have and the code they advocate and advertise and all that. Check one of the sample apps, and they still use enums like this. So
thanks for clearing that up. Cheers.
No. But the interview question will be more likely to ask, what's the difference of an enum and a seal class? That will definitely be asked. I mean, people will ask that. There's a difference. This is the difference. You can go further in the hierarchy. If you want to have one set of elements, one set of constants, but if you want to even further break them into more down, then you can use a seal class. But if it's always going to be the one set, which is something like, always remember this month, that's enum for me straight away. And it's serialized and all that, so you can pass them around, from one class to the other and everything, so it's not broken by any means, Cool. Right. Right. So that's static factory method for us, right? Cool. We'll try an example later. I mean, exercise later, right? For you to try it by yourself. I'll commit this in as well, so that we will have it.
Yes.
And then we have it like this. Cool. What time is it now? So shall we stop here, or do you want to have a look at the other one as well? This is the abstract factory. That'll take another 1 hour or so, to wrap up.
Okay, I have to drop at 2:30, but this is okay.
Okay, no, I don't think we can finish the abstract factory in the next half an hour. I think let's come with a fresh mind and have a look at it.
Okay.
Go to a nice one, let's absorb this a bit more, and then come fresh and have a look at it. Cool. Okay, guys.
Thank you.
In that case, we will say bye then. I mean, that's what I want to show anyway.
That was brilliant.
No problem. Thank you for that.
When you drop the video off, we can then have another look and then get a full grasp and understanding.
Definitely. So far we have studied how many? Three. Yes, so we can mark this as studied as well. Green. I like to mark things as we study,
That's right.
So we're done 3. These are very powerful design patterns,
Okay.
Man. And not only they are letting us to go over the syntax of the code to see the Kotlin and all that, but you're seeing a good pattern here. Whoever is writing code like this, it's a plus, because it's easier because if I look at your code and you know, I see something like this, I can immediately think, you know, this is a static factory you're having, because you're going to create objects here, because that's the
Yeah.
only purpose of having a static factory method, because you will need to create objects, because
Right.
it's part of the creation pattern, right? So it's easier in that way, you know, so for us to communicate. So the purpose will be clear, everyone will understand what we're doing.
Right.
Yeah. Yeah, and it'll make the code looks cleaner as well. You know what I mean? You know?
And you can have many static
Yes.
factory
Yes.
methods.
Yeah. You can have more functions here. As this is inside a companion object, it will make every single thing you define a variable or a function or
Okay.
any function.
So one place for creating all objects.
Yeah, exactly. Yeah, this is being
Okay.
the static factory method. This is the static factory method.
Yeah.
Another static method, but it's not a factory method, you know. If it's going to be a factory method, you will need to create objects, you know, because that's the purpose of it, isn't it? Because that's why we call this as a factory. Yeah.
And this is part of the clean code.
Yeah.
parameter.
Yes, all these things relate to each other. Clean code talks about, you know, I mean, how to keep your code clean by applying standard principles, solid principles. That's another thing, you know.
Okay.
People ask, you know, what's the solid principle? What's it stand for, and this and that. That's again some concepts, you know, which we care about in the code. And these design patterns, on the other hand, you know, which enforces you to apply those, you know, the solid principles and the standards in your code, you know, to keep it clean, because of it's becoming more clearer and cleaner, you know, the code is.
Yeah.
So if I open your code and if I can be able to read it without any struggle, that's clean code, you know.
Okay.
So that, you know, these are there to follow, you know, so that it will always put us in the right direction. Otherwise, we don't know what is cleaner, you know. How do you define, you know, what code is clean? It's hard, right? So, you know. Yeah, but that's why these are there, because we've thought about this many times, because you and me, like, you know, people had these questions before, and then they said, okay, what is then clear? I mean, what is becoming more clear then when people are seeing it much clearer and all that? They've seen this many times, and they've seen a pattern, and they said, so let's put these into some patterns, which will understand. And that's how they've created these concepts, actually. I mean, these are the patterns, you know.
Yeah, I have heard of design patterns, but I didn't know to what extent how powerful they were. I just heard the name.
They are very powerful, man. From all these years I've seen, you know, they're very powerful, because these are the common solutions for all sorts of common problems you can come with software engineering, you know. So it has to be powerful, right? From that sense. Yeah.
No, thanks a lot for letting us know.
You're just seeing simple and clear examples, but what you need to grasp here is why and when do we need to use this? And then even if it gets complicated and complex, the solution will be the same, you know. Might end up a bit more lines of code here, because of this class might get quite complicated because of the requirement we're dealing with and blah blah, but the underlying basic concept or the solution here or the pattern here will remain the same. Nothing is going to change. So I'll have my method to create my objects, which is always going to be the same as, you know, that being in this case the static factory method, right? So we are making our life easier by following these patterns, you know. That's what I'm trying to say. Yeah. So just understand the basics and, you know, grasp the idea behind it, you know. What is each factory or the patterns telling us, you know, the underlying gems of it. I mean, where to use this, you know? Yeah. Cool, guys.
Thank you.
No problem. Wednesday then?
Yeah, sounds good.
Okay, man. All right then. All right, Charlie.
Okay, bye for now.
All right then. See you later, guys.
Bye.
Okay, Charlie. Bye.
Okay.
Bye. Thank you. Bye.
Thank you. No
problem. Bye. I'll speak later. Bye.